Okay, everyone. Welcome to Chapter 1, Section 4, Collecting Sample Data. The key concept in this section is that if sample data is not collected in an appropriate way, the data may be so useless that no amount of statistical tools is going to be able to salvage it. So it's very important that sample data is collected properly. The method used to collect sample data can influence the quality of the statistical analysis. And of particular importance in this section is we are going to introduce the simple random sample. So here's some of the basics of collecting data. Statistical methods are driven by the data that we collect. We typically obtain data from two different sources: observational studies and experimental studies. An observational study is when you observe and measure specific characteristics without attempting to modify the subjects being studied. So for instance, when we've seen maybe examples of psychological studies where they put a box in the middle of the room and say, don't touch the box, and then they put a whole room of children in there, and then they see how the children react to the mystery box. That's an observational study. They are simply watching and measuring specific characteristics, but the researchers themselves don't attempt to interfere at all with the subjects being studied. In contrast with that is an experiment. In an experiment, the researcher applies some type of treatment and then observes its effect on the subjects. Subjects in an experiment are called experimental units, although not the nicest way to refer to people. So, for example, when oftentimes in drug studies, you will have some people in the study that take the medicine and some people that take a placebo. And oftentimes what the researchers are looking for is to see what differences they see in the people who are taking the active drug versus the placebo. So again, they're applying some treatment. Either they're interfering in some way and then observing how that interference affects the subjects. So an example is the Pew Research Center surveyed 2,252 adults and found that 59% of them go online wirelessly. I would gather that that statistic is probably higher now than when this PowerPoint was first made. This would be an observational study because the adults had no treatment applied to them. They just simply asked them, do you go online wirelessly or do you not? And the person would respond, yes or no. In contrast with that, in the largest public health experiment ever conducted, 200,745 children were given the Salk vaccine, while another roughly 201,000 children were given a placebo. The vaccine injections constituted a treatment that modified the subjects. So this is an example of an experiment. Okay, so let's talk about what a simple random sample is now. The technical definition for a simple random sample is a sample of n subjects is selected in such a way that every possible sample of the same size n has the same chance of being chosen. Whew, that is a workout. So let me tell you what that actually means. So for instance, when you're reading the sentence, the letter N is meant to stand in for a number. It's the number of subjects that you're going to study. So rather than use N, let's use 100. Because again, N stands for the number of subjects being studied, and you certainly could have a study where you're looking at 100 subjects. So in that case, a simple random sample would be a sample of 100 subjects that are selected in such a way that every possible sample of another 100 subjects has the same chance of being chosen. So what that means is that in theory, anybody in the population should have the same chance of being surveyed as any other person to make up your sample for your study. Okay, a random sample. Let's talk about what that means. So just like what we were just discussing, what a random sample means is that members from the population are selected in such a way that each individual member in the population has an equal chance of being selected. So let's talk about some different ways of doing sampling. All right, so the first way I'd like to discuss is systematic sampling. Ooh, that's a tongue twister. So for systematic sampling, you're going to select some starting point and then select every kth element in the population. So what that means in English is that you're going to select some starting point, and then every 10th person, 100th person, 1000th person, you're going to ask the question again. So a good example of this is if you go through the Chick-fil-A drive-thru. So I've noticed as a frequent customer of Chick-fil-A that every so often I am asked to take a survey, but it's certainly not every time I come in. So I actually got curious about this and asked them, and they said that depends on the store, but every 100th customer or so, it prints automatically out in the receipt. So Chick-fil-A has no idea whether it's me that's getting a survey or the next person in the car behind me. All they know is that with certainty, every 100th car is going to be asked to take a survey. That would be an example of systematic sampling. The next sampling method I'd like to discuss is what's called convenience sampling. And basically what that means is you use the results that are easiest to get. So for example, if you were doing a survey and asked to do a survey for this class, who might you ask? Your roommates, your friends, your family, coworkers. You're going to go after people that you probably have easy access to. One of the challenges though with convenience sampling is that although it's easy to get at the data, it may not best represent the population. Another type of sampling method is what is called stratified sampling. And a good example of stratified sampling, let me tell you what the definition is first. So in stratified sampling, you subdivide the population into at least two different subgroups that share some characteristic. Then you draw a sample from each subgroup, also known as a stratum. So for example, if you were to ask about cell phone use and you wanted to know differences by gender, maybe you would split your population into men and women, and then you would sample 100 people from each of those groups to get your answer. So this is where, again, you're going to subdivide the population into at least two distinct subgroups that share some characteristic, and then you're going to draw a sample from each of those subgroups, which then allows a comparison between the two subgroups during your analysis. Another type of sampling is what's called cluster sampling. In cluster sampling, you divide the population area into sections or clusters. Then you're going to randomly select some of those clusters. Then you choose all of the members from the selected cluster. So during an election year, this is actually something that happens really commonly. You'll often see that after election, like on an election day, you start to have people calling the election for different people. And this is exactly how they're doing it. So say that there's 20 precincts that are voting on a given day, and they choose 3 of those precincts to represent the entire population of the area. Based on the exit polls from those precincts, they would then project what the results will be for the larger population. So again, cluster sampling is very common during elections, and it's very common when looking at a geographic area and trying to determine a sample from that. Another type of sampling is what's known as multi-stage sampling. This is where you collect data by using some combination of the basic sampling methods. So we have all those different methods that we've already discussed, and this would be where you basically are using a combo. And there's a number of reasons why you might do it. So in a multi-stage sample design, you might select a different type of method for sampling at different stages within your process. So for instance, again, going back to the election examples, during early polling, you may choose one way to do it, and at a later stage, you may choose to use a different method of sampling. And really, it just depends on the type of data that you're trying to get at. But it's not wrong to use a mixture of sampling methods if you do have a longer study that you're trying to use. So in summary, the methods of sampling are random, systematic, convenience, stratified, cluster, and multi-stage. A couple of other things I want to touch upon before we end with Chapter 1. So beyond the basics of collecting data, let's talk a little bit about different types of observational studies and experiment design. So some types of studies that I want you to be aware of. One is a cross-sectional study. This is where data is observed, measured, and collected at one point in time. In contrast with that is a retrospective or case control study. This is where data is collected from the past by going back in time, such as examining records, archives, interviews, and so on. There's also what's called a prospective or a longitudinal or cohort study. This is where data is collected in the future from groups sharing common factors. Those groups sharing those common factors are also known as cohorts. A good example of a cohort is the class of 2016. When that class enters college for the first time in the fall, the graduating class of 2016 from high school, they'll become known as, they would become known as the class of 2020. So that class will be followed by their prospective universities for the different trends. You know, they'll measure what their SAT scores were going in, how well their grades held up over the next 4 years, and so on. Those people will be called a cohort. Another example of that would be what we call kind of age bracket cohorts, things like baby boomers and millennials and Generation X. Those are cohorts that are based on the year or the years that a person was born. And based on that and the culture at that time, those groups are supposed to share common characteristics. So those are some different types of studies for you to be aware of. A couple of things about when you're doing experimental studies. So again, experimental studies are where the researcher is actually applying some type of treatment to their group that they're studying. So something in the design that you want to consider when designing an experiment is randomization. And this is used when subjects are assigned to different groups through a process of random selection. And the logic is to use chance as a way to create two groups that are similar. So for example, we talked earlier about like a type of study where the researcher would apply a treatment, in this case a drug, to one group and a placebo to the other group, or a non-functional drug to the other group, and then compare and contrast the results. Which group the subjects are assigned to should be random. Sometimes people assign subjects random numbers, and that's how they do this, or there's other ways of doing it. But nonetheless, keeping things as random or objective as possible is key. Another is replication. In experiments, you want to repeat the experiment on more than one subject. That way you know that the results that you're getting are not just an anomaly. Samples should be large enough so that the erratic behavior that is characteristic of very small samples will not disguise the true effect of different treatments. It is used effectively when there are enough subjects to recognize the differences from different treatments. The purpose here, and it's a little wordy, but the bottom line is that you need to have enough people in your study to show that the results that you're getting are not just a fluke, but that they actually are really showing you a true trend. And by replicating your experiment on many subjects, it allows you to be more confident in the data. So again, you want to use a sample size that's large enough to let you see the true nature of any effects and obtain the sample using an appropriate method, such as one based on randomness, as we've already discussed. Blinding is another technique that's used in experiments. This is when it's a technique in which the subject doesn't know whether he or she is receiving a treatment or a placebo. Blinding allows us to determine whether the treatment effect is significantly different from a placebo effect, which occurs when an untreated subject reports improvement in symptoms. This is often done because depending if a subject thinks that they're in a group getting a drug, they're actually likely to report different results than if they think they're in a group that is not. And so blinding is a way of helping to alleviate that issue in your design of experiment. Further, there's actually a better way, which is double blind. In the double-blind study, this is where the subject doesn't know whether he or she is receiving the treatment or a placebo, and the experimenter doesn't know either. The best types of experimental studies, in my opinion, are double-blind. Confounding occurs when in an experiment, when the experimenter is not able to distinguish between the effects of different factors. So having confounding variables is something you want to avoid in the design of experiments. And the easiest way to do that is to try to control as many different factors as you can and only have one thing that's really different. So for example, in the case of your patients, they either are taking a drug or they're taking the placebo, but we're not trying out two different drugs on them at the same time. And maybe in order to participate in the study, they require that you don't sign up for any additional studies of that kind or something like that. So basically, the goal here, just like it's to be unbiased, is to also not have confounding variables within your experiments. A couple of other things. How do we control the effects of variables? So a completely randomized experimental design, again, assigns subjects to different treatment groups through a process of random selection. So again, the more randomized you make how people are assigned to the different treatment groups, the better you'll have of controlling for some of these different confounding variables and things like that that we've been discussing. Also, another thing to mention is randomized block design. This is not as commonly used, but it's basically where a block is considered a group of subjects that are similar. The blocks differ in ways that might affect the outcome of the experiment. So for instance, if you're in a drug trial, maybe a block would be smokers and non-smokers. Maybe a block would be men or women. And so it's almost like a subcategory within your experimental design. Matched pairs are another way, and this is where you compare exactly two treatment groups using subjects matched in pairs that somehow are related or have similar characteristics. A good example of this is I used to do breast cancer research, and I would compare women who had breast cancer to women who did not. And one of the factors that I controlled for was age. And so I would actually pair up like a 40-year-old woman who had breast cancer and compare them against a 40-year-old woman who did not. And that would be an example of a matched pair design. And finally, rigorously controlled design. This is where carefully people are assigned to different treatment groups so that those given each treatment are similar in ways that are important to the experiment. So, there's different reasons why you may choose or not to do this or not. It really comes down to the type of experiment that you're trying to go through, and if anyone wants to talk about this in more detail, certainly let me know. So in summary, there are three very important considerations in the design of experiments. You want to use randomization to assign subjects to different groups. You want to use replication by repeating the experiment on enough subjects so that the effects of the treatment or other factors can be clearly seen. And you want to control the effects of variables by using techniques such as blinding and completely randomized experimental design. That being said, no matter how well you plan and execute the sample collection process, there's likely to be some error in the results. And even the most carefully constructed experiments often contain aspects of error. So let's talk through a couple of different types of error. Sampling error is one of the most common, and this is the difference between a sample result and the true population result. And these kinds of errors can result from chance sample fluctuations. So for example, what they're trying to say here is this is where, based on what the sample says, you would expect a certain characteristic about your population, but when you actually look at the population, it's not true. So let's say you were looking at median home income in Western Massachusetts, and you randomly selected people from the neighboring towns. But let's say that instead of selecting a couple of people from each town, that somehow they were all concentrated in one area. So let's take, for example, Longmeadow and East Longmeadow, where Bay Path is housed. Those tend to be relatively high income areas compared to the rest of Western Massachusetts. So if I was to sample people about their median home income in those two towns, and for some reason they were disproportionately sampled just through random chance in my study, I may determine that the median home income in Western Massachusetts is much higher than it actually is. So that's an example of a sampling error. Non-sampling errors can also occur. This is where sample data is incorrectly either collected, recorded, or analyzed, such as by selecting a biased sample, using a defective instrument, or copying the data incorrectly. So those are some different ways that errors can occur. Non-random sampling error can also occur. This is resulting from the use of a sampling method that is not random, such as convenience sampling or voluntary response sampling, which we've already talked through some of the issues with those. Okay, that takes us to the end of section 1.4 on collecting sample data. See you next in chapter 2.